Frau Präsidentin, meine sehr geehrten Damen und Herren, Excellencies, I want to show you geoarchives and explain geoarchives as keys for detecting climate change and the human footprint. I first start with an introduction, then I come to two case studies which show geoarchives as climate change examples, and two case studies which show the human footprint. And then I come to the conclusion. What are geoarchives? For instance, dripstones, stalagmites, or ice cores, or marine sediment cores, they are especially indicative for the paleoclimate. Here we can read the paleoclimate in a long history, and depending on the resolution, also climate fluctuations, small climate fluctuations. And then geoarchives where we can see the human footprint, they are, for instance, lakes, it could be lakes, or floodplains, river floodplains, and definitely harbor basins. And I want to give you some examples of it. The methodology of geoarchaeology, the name tells already, is geosciences and archaeology. It comes together. Of course, we put all information we have into it. We show, study ancient maps, satellite images. We fly our drones, we have DGPS, and then what I marked in red, this is especially what we are doing. We are doing corings, and with the corings, we can, so to speak, the sediments, this is the book we are reading. This is our book. You see the sediment core here of 8 meters, the first meter, second, and so on, 8 meter and 40. It's a sediment core, and now the sediments are analyzed according to the microfauna, the macrofauna, and the palynology, for instance. We go into geosciences, geochemistry is an important tool also, and then we combine it together with geophysics, geophysical information, as has been shown just in the lecture by Madame Bamfi, and we put into it also information, of course, from archaeology, from ancient history, and then the synthesis of it all. When it all comes together, this is the landscape evolution. Here, in this case, it's Troy and the evolution of the Karamanderes, the Scamander Delta in Turkey. There's just a book out, 445 pages, 80 authors have contributed. It's the first textbook on geoarchaeology, and I can really recommend it. It's just 1 month ago, it was published. I come to the first example. This is on 2 sites in the now arid zone. What is the BWH, so the hot desert zone, according to Köppen-Geiger. And 2 examples, which I did in cooperation with the DAI, the Orient Department. The first example, I show you first sites where we have the paleo record of the climate. This is, for instance, from lakes, from caves, and also from the Dead Sea. And now I turn to Tama. Tama is an oasis, and the finds around go back to the 7th millennium BC even. But for us as geoscientists, it was more important to go into the sink, where the sediments, so to speak, are deposited. And the sink is the Sapka, the salt pan, which you can see here to the north. Now, when we go there today, it's a total desert. It's only a crust of gypsum. But the sediments tell us, and the trenching which we did, they tell us there was once a lake, and the lake was 13 meters deep. So we heard already a little bit about the Green Sahara. So this was actually a phase when we had a lake. Definitely climate was totally different at that time. And we have different proxies. The article is just published, Neugebauer et al. She's also in the audience, some of the co-authors. You see that when you have annually layered deposits, then you can even say in which year was what. Of course, we are based on radiocarbon dating, but also on tephra. So we have a good anchoring of the age depth model. And there are different proxies which tell us the rainfall, evaporation, the productivity of the lake, and so on. So that's a really nice example of that climate change in that let's say 6,800 years BC. So that was a perennial lake, so a persisting lake in that time. I go to another example, in this case with Margarete van Es from the Orient Department of the DAI. This is now Uruk, Varka. It's an interesting tell. It's 16 meters high, and it was here that the writing was invented. The cuneiform lettering was invented, and the brewing of beer was invented. So later in the evening, when you have a beer, think of it. It was invented here. That's an important technology, of course. Yeah, and it's the city of the legendary King Gilgamesh. And you see the city wall in red, and I drilled just in front of this, what is called the Steingebäude, and the drill core tells us nicely the story of the evolution of the landscape. It starts with the desert. Indeed, we have dunes in the desert. This was when it was all dry at the beginning of the Holocene, a little bit earlier even. And then comes the alluviation, so the flooding of the Tigris and Euphrates River and the other rivers coming together. So it becomes wetter. And then comes a marsh environment, so even wetter, because also the sea level rise in the Arabian Gulf. And then 5,000 years of the history of the site, the mega city of Uruk, as Margarethe van Es calls it. Now there was geophysical data, as we can see here, and they were interpreted as canals. There must have been canals through the city and also outside, but evidence was needed that it was really canals. So we drilled inside and outside, and yes, we found out, we can say what I marked in blue here, these are artificial waterways. So we called it Amsterdam in the sand. Artificial waterways because we have little pieces of rolled ceramics, we have freshwater fauna, we have with a disconformity, erosional disconformity, the sediment starts. So it's quite good proof. And there is a cylinder seal which shows how people at that time navigated. And now Margarethe van Es was lucky enough to even find a boat and excavate a boat. So this is quite definite proof. When you look at it at the beginning of the last century, even people lived in these conditions. So it's a long tradition of water management, you can say. You see again on the other side, on the left side, you see the city wall, and outside you see gardens, and they are watered. So when we look at it today, it was at that time with the Sumerians, it was an excellent irrigated horticulture, you can say. Now, when we look at it today, it's a desert, it's nothing. And we call it inverted channels. So the canals, which were normally a depression, now they stick out because the sediments are cemented with calcium carbonate. So they stick out, they are stronger. And the rest, the gardens, they had a horticulture, the gardens gone with the wind. The wind blew out the material and you see the dunes in the back. And that it was totally different, you see by the freshwater mollusks, which you see here. And indeed, what we found out, not us, but others in the stalagmites, for instance, Sorak cave in Israel, you find that droughts are very devastating, of course, to the cultures. This is the cultural collapse. We see the 5.2 kilo-year rapid climate change event and the 4.2 rapid climate change event. This led to salinization of the fields, and the people finally had to migrate. They had to move because it was not possible to live there anymore. The Sumerians had to move more north. There's a book just out by Gerold, and it shows the connection between the climate change and the collapse of civilizations. And I can recommend it. It's just out a couple of months ago. We turn the page and we come now to two examples where I see strongly the human footprint. I go to harbors. And here we have the city of Ephesus. Many of you know it by own eyesight, or you know it from the Bible, Paul's letter to the Ephesians. You know it from the Artemision in the center below. You see the Artemision site, one of the 7 wonders of the ancient world. So it's really a hotspot of archaeology. In this case, I did it with the Austrian Archaeological Institute and Sabine Ladstätter and team. But when you look close by, there is a lake, Lake Bellevue. And this is a quasi-natural environment. So you can compare the natural evolution with the human footprint geoarchive. And you see the progradation of the, what we call the Küçükmenderes, the Kaistros of ancient times. It was a marine embayment when sea level rose. After the Ice Age, sea level rose. It created gulfs, extended marine embayments, and then the rivers, since 7,000 years, the rivers put out their deltas. And you see a special rapid delta growth in Greek and in Roman times. So again, there's stress on the environment and a lot of sediment, and the river can put out the delta to the west strongly. We go now to the Roman harbor of Ephesus. And in our drill course, we see the time when it was intensively used. Because in that time, you see pollution with heavy metals. This is, for instance, lead. This is copper. In the time of the intensive use, and when the city is more or less given up, you see that these contaminations, they decline. And we have literary resources. Now comes ancient history into the picture. We know that the harbor basin was dredged, and we see this dredging with a disconformity. We know that the harbor was extended. We can also see that. And finally, there is a decree of a consul who says you should not put waste into the harbor basin. And we see the waste. Here it is. For instance, you see in the lower part, this is the natural lake of Bellevue I was just talking about. When you look into the upper part, the harbor basin, you see one mineral. Now we are heavy mineral analysis. One mineral which is not in the natural. This is corund. And corundum is an emery. You polish the marble with it. So indeed, Pliny the Elder tells us that with corundum you do it. And there is the decree of the consul who says it is not, you should not put this powder and the stuff into the harbor basin. And we found it. Here is the pollution of the harbor, so to speak, with the heavy minerals. In this case, corundum. I go to my last example. I come north of Ephesus. We have Elaia. This is the maritime city, the maritime harbor of Pergamon, a cooperation with Felix Pierson from the DIE Istanbul. And it is the closed harbor I'm now addressing. It is this number 1, which you see here. What do we find in the closed harbor? Well, it was a nice cooperation with Ludmila Schlomikowski from Göttingen. We find eggs of intestinal parasites of humans and of animals. We find spores of fungi that grow on manure. So this is an indication of pastoralism, goats and sheep. We find, again, spores of fungi that live on roots. And if the roots are exposed due to soil erosion, then the fungi are in the sediment. And we find, and this is quite nice, a dinoflagellate. This is phytoplankton and a special species. And this species is endemic to the Black Sea. So when we find it in Elaia, of course, there is seafaring. It's an indirect proof of the seafaring in those ancient times. When I look at the pollen diagram, I see that before the human impact, we have a deciduous oak forest. This is what we call the climax vegetation. It's a deciduous oak forest, which is quite open, relatively open. But in the heyday of Elaia, this is 250 BC to 180 AD, what do we see? A reduced forest cover. So they cut the forest, of course, part of it. And then we see olive groves, walnut, and so on, cerealia. So this is, of course, the strong human impact. And we see, again, intestinal parasites, the eggs, and we see a high amount of charcoal. We are the fire species. So here you see it. Take-home message. We have, of course, geoarchives, which tell us the climate change, different kinds of geoarchives. And if the resolution is high and we can date it very well, if it is annually varved, for instance, annually layered, we can even see minor fluctuations of the climate, like these rapid climate change events. However, often in the archaeological context, the human footprint is even stronger. It's overprinting the climate signal so that we can't see it, the climate signal, so well. And this holds especially true for civilizations which are very old or which have a long history of settling, like in the Mediterranean. The human footprint, of course, we know from deforestation, from cultivation of fruits, trees, from all kinds of things, and also fire ecology, as I just said. And I think especially important was Neolithization, the introduction of the iron plow and the herding of goat, because goat are devastating for the forest. I think the greatest danger, though, for the cultural heritage at near coastal areas, this is indeed the strong storminess which will increase, as we know. This is an example from Ampurias. Dirce Mazzoli will talk about this. So storms and storm surges will increase and attack those sites which are near coast. And then we have the IPCC. It was just mentioned, IPCC 2021. The prognosis is that till 2300, sea level will be at +7 meters. Yes, 15 meters cannot be excluded. That's written there. And think of 15 meters sea level rise. This is devastating, of course, for all societies living near coast, not to speak of the coral islands and so on. My last slide talks about a totally different archive. We just heard it. This archive of the DAI at Melaune near Görlitz. And I'm very happy that I could give my samples in the cooperation with the DAI to this archive. Why do we need archives like that? Well, here the samples are preserved. They are not thrown away. Following generations can work with it. And it is, of course, very important, especially in countries where you cannot export samples anymore, like Turkey, Egypt. It's important where, for instance, countries which are at war, like Russia, Ukraine now, Yemen, you name it, you know it. And of course, in 10, 20 years, we have different methods, different analytical methods. So the new generation can study this. This is wonderful. And my last word is a big thank you to the DAI for this long-standing, very friendly and very open and very good cooperation. Thank you very much for that. And I thank you for your nice attention.